Let's talk about Kerberos delegation. Kerberos delegation stands a pivotal functionality in Active Directory, enabling users or services to represent others in accessing resources. This capability plays a critical role in enhancing user interactions and authorizing reliable services to securely access necessary resources. However, a deep comprehension of Kerberos delegation, particularly the differences between constrained and unconstrained delegation, is crucial for upholding a secure and effective Active Directory framework. In this detailed topic, we will venture into the complexities of Kerberos delegation, examining its mechanisms, practical uses, and security aspects. Let's talk about double hop problem. The double hop problem is a specific challenge that arises in delegation scenarios, particularly in the context of multi-tiered applications or service-to-service communication. It refers to the limitation where a service which has received delegation credentials cannot further delegate those credentials to another service. This constraint is a security measure in Kerberos authentication and is designed to prevent unauthorized escalation of privileges. Let's talk about the double hop problem. First, a user logs into a client application. Client applications on behalf of a user request a ticket granting ticket from key distribution center. Then the client application needs to access a middle tier service such as application server. The KDC verifies the TGT and issues an service ticket for the requested service. The client application presents the service ticket to the middle tier service. The middle tier service verifies the service ticket with the KDC and authenticates the client. The challenge arises when the middle tier service needs to access another service such as database server on behalf of the user. Here we encounter the double hop problem. By default, Kerberos does not permit middle tier services to pass user credentials onto second hop services, providing an extra layer of security against an escalation in privileges. To overcome the double hop problem challenge and enable secure delegation for the second hop, organizations can configure delegation in Active Directory. With delegation, the middle tier service can specify which specific services it is allowed to delegate the user's credentials to. This controlled delegation ensures that only authorized services can be accessed on behalf of the user for the second hop, maintaining security while enabling multi-tiered application scenarios. By implementing delegation, organizations can strike a balance between security and functionality, allowing for the seamless flow of authentication and authorization in complex multi-tiered application environments. Now let's discuss about the types of Kerberos delegation. First up, we have unconstrained delegation. Unconstrained delegation is a configuration option available for user or service accounts within Active Directory. When an account is granted unconstrained delegation rights, it essentially means that this account can delegate its TGT to any service within the domain without any restrictions. This delegation setup simplifies the process of allowing services to act on behalf of users but comes with inherent security challenges. An account with unconstrained delegation privileges possesses a significant level of authority. Such an account can impersonate any user within the domain because it can delegate its TGT to any service. When an unconstrained delegation service receives a TGT from a user, it can use that TGT to request service tickets on his or her behalf for other services without needing the user to authenticate again. Which provides seamless access to various resources. Enabling unconstrained delegation on a computer leads to a situation where whenever an account connects to that specific computer, their granted ticket obtained from the key distribution center is temporarily stored in the computer's memory. If the computer becomes compromised, an attacker could potentially access and misuse that stored TGT. This poses a significant security risk, specifically if the compromised TGT belongs to a highly privileged user, as it could allow the attacker to inflict substantial damage within the network. Let us now identify if there are any systems that has unconstrained delegation in our domain. For that, open PowerShell and load PowerView. Now we can use getNetComputer -unconstrained and then select the name. We can see that both the DC and the test machine pen test has unconstrained delegation enabled. Unconstrained delegation is enabled by default and required on all domain controllers and might not be useful for us since we do not have access to it. But unconstrained delegations is also enabled in our test machine. This means that the machine will store the TGTs of the incoming request in the cache which we can use to perform a pass the ticket attack later on. We can use Rubius on this account to listen for incoming authentication attempts. In order to monitor for incoming connections with Rubius, we need to run the following command from an elevated context. Rubius monitor, then specify the interval of 2 seconds. We can already see a number of TGTs that have been captured, including a domain controller. This is how it was intended in the lab, so we can ignore it for the moment. In a real world scenario, you might have to wait for a high privilege user or service to authenticate to capture its TGT. Let us assume that we do not have a TGT of a high privilege user here and we cannot wait till a user logs in. This is where the spooler bug comes into play. The spool sample attack revolves around a critical component of Windows operating systems, the print spooler service. This service is responsible for managing print jobs, including their queuing and processing. It plays a vital role in facilitating printing tasks on Windows machines and is typically enabled by default. We can use this to trigger authentication from the domain controller into the machine with unconstrained delegation present to capture the TGT of the domain controller. Before that, let us see if print spooler service is enabled in the domain controller. We can do so by running //dc/pipe/spools. We can see that it gives an output without any errors. This means that the service is up and running on the DC. Now we can use spool sample to trigger authentication. You can download and compile the binary from the GitHub repo or use the provided binary in the tools folder. Run it with the target machine /spoolsample.exe, then DC, then pentester. Once it triggers authentication, go back to the Rubius. We can see that it has captured the TGT of the DC. This can be further used to extract credentials using TC sync. Now let's talk about constrained delegation. Realizing the potential dangers of unconstrained delegation, Microsoft introduced constrained delegation with the release of Windows Server 2003. This new approach was designed to limit the scope of what service a machine or account could access while impersonating other users. The key here was control and specificity. Constrained delegation uses two specific protocol extensions, S4U to self and S4U to proxy. These extensions are critical in managing and limiting delegation permissions. Let's talk about S4U to self. This extension allows a service to request a ticket for itself on behalf of a user, particularly useful when a user authenticates using non-Kerberos methods. Now let's talk about S4U to proxy. This extension enables a service to use the obtained ticket to request access to other services, but only those specified in a list of allowed services. Moreover, a feature called protocol transition is enabled. This allows services to transition user authentication from non-Kerberos to Kerberos, enhancing interoperability and maintaining security. In Windows environments, Active Directory plays a crucial role in managing constrained delegation. Service accounts within Active Directory can be configured with specific services they are allowed to access, denoted by their service principal names, in short SPN. Additionally, two fields in the Active Directory objects become particularly important. First up, we have MSDS allowed to delegate to. This field lists the specific SPNs to which account can delegate. Next up, we have user account control. If this includes trusted to auth for delegation, the account can impersonate any user for the SPNs listed in MSDS allowed to delegate to. While constrained delegation significantly reduces the risk associated with the older unconstrained method, it's not foolproof. The system security hinges on the proper configuration and management of these delegation settings. If an account with delegation rights is compromised, it could still pose a security threat, albeit a more controlled one compared to unconstrained delegation. The evolution from unconstrained to constrained delegation showcases Microsoft's commitment to enhancing security in its server environments. By understanding and correctly implementing these features, network administrators can significantly reduce the risks associated with delegation. However, it's a continuous process of learning, managing, and adapting to new security threats. The following section will explore resource-based constraint delegation, the third type of Kerberos delegation.